Okay, part two. My card got full, so I had to stop. So I'm not exactly sure where it ended off. I'll go back and try to slice it in as best I can. But I wanted to show you a video that's a pretty good representation of antibodies versus antigens. And I wanted to make sure, I can't remember, I don't know if this got cut off in the last part. I want to make sure that you understand the difference between innate immunity and acquired immunity. Innate immunity is something that everybody's born with because everybody's born with white blood cells, the neutrophils, the eosinophils, the basophils, all of those will kick in the presence of an infection. Everybody has that. It's not an acquired thing. But as people develop and get older, when the body is exposed to an antigen, and I will show you what that looks like in a second, which is basically something the body doesn't like. It could be a virus, malignancy, something that the body doesn't like. That is an antigen, and the body will develop antibodies to it. That is called active acquired immunity. So if this is why we vaccinate babies. So if we give a baby a little bit of a chicken pox or measles, mumps, rubella, something like that, we give them a little bit of it, the body will then develop antibodies so that when they get exposed to the virus again, the body can recognize that's a foreign object, we don't like it, and it will initiate the immune response so that virus cannot overwhelm the body. That's active acquired immunity. Passive acquired immunity is, and let me go back. Active acquired immunity, it lasts forever. So once somebody has developed an active acquired immunity, it's there for life. So once you get chickenpox, you're not going to get it again. Once you get the measles, you won't get it again. And that's why we vaccinate kids so that they don't get these types of diseases. Passive immunity is it is a basically synthetic kind of immunity. It is somebody who's receiving an antibody rather than the body is developing it. So that's why we give people immunoglobulins. Like if you're taking care of a patient who has Hep C or has an infectious disease, and you get stuck with a needle, you will go to employee health and you will get a shot of immunoglobulin. Or some people that I was just describing earlier who have immunodeficiencies will get IV immunoglobulins, and that is a synthetic form of antibodies which help fight off disease. That's passive acquired immunity. The difference between passive and active is passive doesn't last forever. It's a temporary fix to a problem. So patients who get IVIG, you got to come back again. Or if you get poked, taking care of a patient with Hep C one time, if you get poked again, you're going back down and get more, another immunoglobulin shot. So I wanted to make sure that I made that clear between the difference between active and passive and acquired types of immunity. Now I want to show you this video that describes the antigen antibody process, and then how the T cells and B cells within the immune system kick into play. So, all right, so hopefully I'll do it better this time.
Of the immune response typically begins when a pathogen enters the body. Macrophages that encounter the pathogen ingest, process, and display the antigen fragments on their cell surfaces. Macrophages with antigen fragments displayed on their surfaces are called antigen-presenting cells. An antigen-presenting macrophage interacts with a T helper cell that can recognize the same antigen. During the interaction, the macrophage releases a chemical alarm signal called interleukin-1, which stimulates the T helper cell to secrete interleukin-2. Interleukin-2 causes the proliferation of certain cytotoxic T cells and B cells. The immune response from this point follows two paths, one using cytotoxic T cells and one using B cells. Normal cells of the body that become infected can also digest some of the pathogens and display antigen fragments on their cell surfaces. The body makes millions of different types of cytotoxic T cells. Each type is able to recognize a particular antigen. The cytotoxic T cells that are capable of recognizing the antigen displayed on the surfaces of infected cells bind to the infected cells and produce chemicals that kill the infected cell. Death of the infected cells results in destruction of the pathogen. B cells also come in millions of different types, each able to recognize a particular antigen. When B cells become activated by T helper cells, they differentiate into plasma cells. These plasma cells become antibody-producing factories, flooding the bloodstream with antibodies that can bind to the antigen involved in this infection. Antibodies bind to the antigens on the surfaces of the pathogens, marking them for destruction by macrophages. Some of the B cells do not turn into antibody factories, but instead become memory B cells that may survive for several decades. Because of these memory B cells, the secondary immune response to a future infection by the same pathogen is swifter and stronger. This powerful secondary immune response is what gives immunity to some diseases after you have had them once or after you have been vaccinated.
Okay, so I hope that helps to clarify the immune
Every second of your life, you are under attack. Billions of bacteria, viruses, and fungi that...
Sorry. Okay, whoops. Yeah, so hopefully that helps you to differentiate the immune system, what the immune system does in conjunction with the white blood cells. So they work together, but they're different systems, and it's important just as the nurse to know, one, how to prevent infection and problems in your patients who are immunodeficient, how to recognize patients who have immunodeficiencies, some complications that can occur. Like I said, people that have immunodeficiencies are at higher risk for developing autoimmune disorders like lupus and RA. And how to recognize those, how to treat them. The patients are often on steroids just to suppress the immune response of patients who have like organ transplants and things like that. So, okay, so spend a little bit of time reading the chapter. It is a little bit of a complicated system, but once you understand it, it really helps you figure out why some of your patients respond certain ways to certain diseases. Okay, chapter 37 is next.